The potential energy of a particle moving along the x direction varies as v equals ax square by root x plus b. The dimensions of a square by b are. So when we can see here that root x plus b. So therefore b must be having the dimensions of root x. Not b is equal to root x, but the dimension of b should be equal to the dimension of the root x. So which is meter to the power 1 by 2. Now this is energy, because this is potential energy mentioned. So therefore joule is equal to A into x. X is in meters. Why x is in meter? Because it's written there that the particle is moving along the x direction, and therefore ax square. So therefore x has to be in meters. So a meter square divided by, so both of them are meter to the power half. So therefore we do this. So therefore a becomes joule meter half divided by meter square. So that is Newton meter kg ms minus 2 into m kg, okay, into meter half divided by meter square. Gone. So this is kg m half s minus 2. So the question is, what is the dimension of a square by b? So therefore a square by b, the dimension becomes kg square meter to the power 1 s to the power minus 4 divided by b, which is m to the power half. So therefore that is kg square m to the power half s to the power minus 4. So this is m square l to the power half t to the power minus 4, which is the option number C. Thank you. The quantities which have the same dimensions as those of the solid angle. So now what is solid angle? Solid angle is like we have a sphere, and that a part of the sphere is connected to the center. So when it is connected to the center, it is subtending an angle, a solid angle, and that solid angle is given by omega. So this solid angle, when it is subtended in the center, the area of that small portion which of the cone, that is sigma into r square. Okay, so this is the surface area, and this divided by r square, that gives us the solid angle. So therefore the solid angle, again it's a ratio. Okay, so therefore solid angle is dimensionless because it is a ratio. So therefore here also we can see it like meter square by meter square, so they get cancelled. So therefore it is a dimensionless quantity. Now which all are dimensionless quantities, that's what we have to see. The stress is force divided by area. So this is Newton per meter square. So therefore this option is not correct. Angle, yes, angle again it is the arc length divided by the radius. So again here also it's going to be meter by meter. So this is again a dimensionless. So angle is dimensionless. Strain is dimensionless because that is delta L by L, the extension in length divided by length. So therefore this again becomes meter by meter and gone. You know, it is also a dimensionless quantity. Arc is again length. Okay, so we have it in meters. Angular speed, it is radian per second. So this is per second. So again this is also having dimension of t to the power minus 1 per second. Stress we already saw, F by A. So therefore strain and angle, so the option strain and angle, both of them are dimensionless. So therefore the correct option is D. A force defined by F is equal to alpha t square plus beta t, which acts on a particle at a given time t. The factor which is dimensionless if alpha and beta are constants is. So F is equal to alpha t square plus beta t. So now this F, this force is in Newton. So therefore alpha t square also must be in Newton and beta t also must be in Newton. So I'm writing here alpha t square is in Newton and beta t is also in Newton. So what's going to be dimensionless? That's what they're asking. So if you see, if we divide by beta t is also in Newton. So gone, t is gone. So therefore alpha t by beta, this becomes dimensionless. Okay. So why we divided? Because we just saw that alpha t square is in Newton, beta t is also in Newton. So when they are divided, Newton and Newton are going to be cancelled. So therefore alpha t square by beta t has to be dimensionless. So therefore the option number A is correct. Thank you. The mechanical quantity which has the dimensions of the reciprocals of mass m inverse is. So torque is R cross F. So this is in meters and force is in Newton. So this is meter into kg ms minus 2. So this is kg meter square per second square. So this is m l square t minus 2. So of course this is not having m to the power minus 1. For gravitational constants, so it is Newton meter square per kg square. So this is again kg ms minus 2 m square kg square. Gone. So this is m minus 1 l cube t minus 2, because kg goes up, so it will become kg to the power minus 1 and kg is mass. Okay, so therefore B is the correct answer. Angular momentum r cross mv, r cross p, which is meter into p is kg meter per second. So this is mass length square t to the power minus 1. Again this is also not having m to the power minus 1. And the coefficient of thermal conductivity, so this is dq by dt is equal to ka delta theta by delta x. So q is in joule, time second, k is the coefficient of the thermal conductivity, area meter square, delta theta, that is the difference in temperature, is T, and delta x is in meters. Gone. So therefore the thermal conductivity is going to be joule divided by second into meter into temperature, which is Kelvin. So kg ms minus 2 into m divided by second into meters into Kelvin. Gone. This is s power minus 3. So therefore mass to the power 1, L to the power 1, T to the power minus 3 and Kelvin to the power minus 1. So of course this is also not having m to the power minus 1, it is having m to the power 1. So therefore the only option which is going to be correct is B. Thank you. The same dimensional formula as pressure. So pressure is what? Pressure is force divided by area. So this is Newton per meter square. Now this force is in Newton, so of course this is not the answer. Momentum is kg ms minus 1, which is actually Newton, which is kg ms minus 2 second. This is not the answer. Young's modulus of elasticity, Young's modulus is F by A delta L by L. So now this is F by A and delta L is in meter by meter, which cancels it out. So therefore the dimension is going to be F by A only. So therefore yes, C is going to be the answer. Let us discuss about the coefficient of viscosity also. So F is equal to neta A dV upon dx. So therefore Newton is equal to neta meter square meter per second, this is the velocity, difference in velocity, divided by meters. So here also we see that neta is getting multiplied, so Newton second by meter square. If it was Newton per meter square, then it would have been done. So yes, C is the option. Now someone may feel that why I have just like kind of written like this, Newton per meter square, I should have simplified it. Yes, you can as well simplify it, the answer is not going to change, but seeing the options where more or less everyone is centered around Newton, so therefore we can do this. Thank you. Plane angle and solid angle have. So plane angle, okay, so plane angle is arc length divided by the radius. Now arc length is like this is in meters, radius is also in meters, so therefore this is going to be L to the power 1 minus 1, which is L to the power 0. So it like the unit is there, but the dimension is 0. Okay, same with solid angle, which is surface area divided by r square. Of course, surface area of the cone, the part of the cone which is the part of the sphere, and it is subtending an angle of sigma at the center. So this is again meter square by meter square, which is L to the power 2 minus 2, L to the power 0. It is having again unit, but the dimension is not there, so therefore they are having units but no dimensions. Thank you. The dimensions belong to the self-inductance. So self-inductance is phi is equal to L into I, which is B into A is equal to L into I. So therefore L becomes B into A divided by I. Now what is B? So F is equal to QV cross B. So therefore B is F by QV. So therefore we can write L is equal to F, that is Newton, divided by Q, which is Coulomb, velocity, which is meter per second, into area, that is meter square, and divided by the current, which is Coulomb, by, of course, Coulomb, current is an ampere, and we can write this Coulomb as ampere into second, because ampere is a fundamental unit but Coulomb is not. So gone, this is also gone, so therefore this becomes Newton meter per ampere square, so which is kg ms minus 2 m divided by a square. Okay, so this is m L square t minus 2, m L square t minus 2 and a minus 2. Okay, now here L is being given. Okay, so therefore we can see, if we see BA by I is going to be ml square t to the power minus 2 a to the power minus 2. So self inductance is not there. Okay, now is something, magnetic flux, which is again B into A, that means L into I. So this is L, so if I multiply L into I, so just the ampere will get multiplied here, so L is not going to change, so therefore this is also not there. Magnetic permeability, let us see. So B, by the Biot-Savart law, the magnetic field is equal to mu naught by 4 pi I dl cross r by r cube. So again, this is B into meter cube divided by ampere into meter square. Gone. So this is B into m by a. Now B into meter by ampere is this. Okay. So what we do is B into meter square by ampere is this. So therefore B into meter by ampere we divide by the length L. So now this comes as L to the power 1. So therefore magnetic permeability is fitting in. Okay, electric permittivity, which is epsilon naught. So let us do for that also. So 1 by 4 pi epsilon naught into q1 q2 by r square. This is in Newton. So therefore epsilon naught is going to be Coulomb square divided by meter square into Newton, which is kg ms minus 2. Now here mass is going to be inverse, so therefore this also is not fitting in. So therefore the only option which is fitting in is B. So therefore B is the option. Match list 1 with list 2. So gravitational constant G. So force is equal to G m1 m2 by r square. So therefore G is equal to Newton meter square per kg square. So this is basically kg ms minus 2 m square by kg square, which is gone. So mass to the power minus 1, L to the power 3, T to the power minus 2. So this fits in here. So A option, it's 2. Now we will not look at B because B is also like same. So we'll look at C option, gravitational potential. So what is gravitational potential? Gravitational potential is G into m by r. So m to the power minus 1 L cube T minus 2 into mass, which is kg. So mass divided by r, which is L. Gone. So this is L square T to the power minus 2. So gravitational potential marks to 1. So C is 1. Okay, and let us prove for the other also. Gravitational potential energy is going to be in joule. So joule is Newton meter, which is kg ms minus 2 m. So kg m square, so m L square T to the power minus 2. B goes to 4. And D, which is gravitational intensity, which is basically the acceleration due to gravity, is the gravitational intensity of Mother Earth on the surface of the Earth. So that is meter per second square. So that is L T to the power minus 2. So therefore D goes with the third option. Okay, so therefore the A option is correct. If E and G respectively denote the energy and the gravitational constant, then E by G has. Okay, so gravitational constant is G. So if we see the gravitational potential energy, it's going to be G m1 m2 by r. So therefore E by G is going to be kg square by r, which is m square L minus 1. So therefore C option is going to be correct. If force, acceleration and time are chosen as the fundamental physical quantities, find the dimensions of energy. So energy, that is joule. Okay, so force, acceleration, so we can write here f to the power a, acceleration to the power b, t to the power c is equal to joule. So kg ms minus 2 into m is equal to force, which is kg ms minus 2 to the power a, acceleration ms minus 2 to the power b, and time s to the power c. So this becomes kg meter square s minus 2, which is kg power a, m to the power a plus b, and s to the power minus 2a minus 2b plus c. So now we compare. So a is going to be 1, a plus b becomes 2, so therefore b also is going to be 1, and minus 2 should be equal to minus 2a, which is minus 2, minus 2b, which is again minus 2, plus c. So c is going to be 2. So f to the power 1, a to the power 1, t to the power 2. So fat square. Okay, so that's going to be the answer. Thank you. Dimensions of stress are, so stress is force divided by per unit area, so therefore Newton per meter square. So kg ms minus 2 by m square, which is kg m to the power minus 1 s to the power minus 2 m l minus 1 t to the power minus 2. C option is the correct. Unit of thermal conductivity is, so of course we have delta q by delta t is equal to ka into delta t, there is a temperature difference, divided by x. So therefore k is going to be delta q, which is in joule, into x, which is in meters, divided by delta t, which is time, which is seconds, into area meter square into Kelvin. So now what is joule? Joule is Newton meter, so therefore kg ms minus 2 Newton meter, again meter, divided by second meter square into Kelvin. Gone. So this becomes kg m, the s minus 2, s minus 3, k minus 1. So this is m l t to the power minus 3, k to the power minus 1. Oh, so here it's being given in okay, joule and watts. Okay, so of course it's going to be joule, m to the power minus 1, s to the power minus 1, k to the power minus 1. Okay, so this is not the correct, this is not correct. Now joule per second is watt, so therefore watt per meter per Kelvin is correct, so therefore D option is going to be correct. A physical quantity of the dimension of length that can be found out of this is, okay, so c is in meter per second, velocity of light. G is Newton meter square per kg square, and E square by 4 pi epsilon naught. So of course we have this force is equal to K into Q1 Q2 by R square, which is basically 1 by 4 pi epsilon naught into E square by R square. So this is going to be Newton meter square. This is going to be Newton meter square. Okay, now what we have to do is we have to arrange it in such a way that meter is going to come up. So meter is going to be ms minus 1 to the power a. Now Newton meter square per kg square, which is kg ms minus 2 m square by kg square to the power b. Newton meter square, which is kg ms minus 2 m square to the power c. So therefore this becomes m to the power a plus 3b plus 3c, kg minus b plus c, second minus a minus 2b minus 2c. So minus b plus c should be equal to 0, so therefore b is equal to c. Okay, then minus a minus 2b minus 2c should be also equal to 0. So minus a minus 4b is equal to 0, so therefore a is equal to minus 4b. Okay, and a plus 3b plus 3c, now b equals to c, so therefore a plus 6c is equal to 1. So therefore we can write here minus 4c plus 6c is equal to 1. So therefore 2c is equal to 1, c is equal to half. So when c is equal to half, b also becomes half, and a becomes minus 4 into half, so this is minus 2. Okay, so this is c to the power minus 2, g to the power half, and e square by 4 pi epsilon naught, that also to the power half. So therefore this is the option number A. Thank you. And Newton's gravitational constant g are the three fundamental constants. Which of the following combinations of these has the dimension of length? Okay, so Planck's constant, so we have hc by lambda as energy. This is the energy of a photon, which is joule. So therefore h is equal to joule into lambda by meter per second, which is joule meter by meter per second, gone. So this is joule second, this is h, and this comes out to be Newton meter second, so kg ms minus 2. So this joule can be written as Newton meter, so therefore kg ms minus 2, this is Newton meter into second. So this is kg m square s minus 1. Now speed of light in a vacuum, so c is ms minus 1 and g is Newton meter square per kg square. So therefore kg ms minus 2 into m square divided by kg square, gone. So this is kg to the power minus 1 meter cube s to the power minus 2. Okay, now which of the following combinations has the dimension of length? Okay, so let us do this. So kg meter square per second to the power a, meter per second to the power b, and kg to the power minus 1 meter cube s to the power minus 2 to the power c is equal to meter. So this is kg a minus c, then meter, 2a plus b plus 3c, and s minus a minus b minus 2c is equal to meter. So therefore a minus c is going to be 0, a is equal to c, 2a plus b plus 3c equals 1, which is 5a plus b is equal to 1, and minus a minus b, so minus 3 minus 3a minus b is equal to 0. Okay, because I have replaced here in this a is equal to c, so therefore minus 3a minus b is equal to 0. So b is equal to minus 3a. So therefore here we have 2a is equal to 1. So therefore a is equal to half. Since a equals half, c also is half. And b is minus 3 by 2. So therefore it's going to be h to the power half, c to the power minus 3 by 2, and g to the power half. So hg by c cube root. So that is the A option. The dimensions of critical velocity of a liquid flowing through a tube are this. Okay, so then the value of x, y and z are. So critical velocity is basically in meter per second. This is equal to neta. So now let us find out what is neta. So for neta we have this formula, F is equal to neta A dV by dx, or you can use even the Stokes law, where the force is equal to 6 pi neta RV. So from both, neta comes out to be force divided by RV, which is force divided by meter into meter per second. So therefore this is Newton by meter square per second to the power x. Now rho is the density, so this is kg per meter cube to the power y, and radius to the power z, which is meter. Okay, so let us solve this. So this is kg ms minus 2 by m square s minus 1. Gone. This is minus 1. So this becomes kg m minus 1 s minus 1 to the power x, kg m minus 3 to the power y, and m to the power z. So this is kg x plus y meter minus x minus 3y plus z second minus x. So meter per second. Okay, now we have to equate with this. So for second it's minus 1, so therefore minus 1 is equal to minus x, so therefore x becomes 1. Okay, and for kg x plus y equals 0, so therefore y becomes minus 1, and minus x minus 3y plus z is equal to 1. So therefore minus 1 plus 3 plus z is equal to 1. So 3 minus 1 is 2, so z becomes minus 1. So 1 minus 1 minus 1. So that is the option D. Thank you. If energy, velocity and time are chosen as the fundamental quantities, the dimensional formula of surface tension will be, so surface tension is force per unit length. Surface tension is equal to force per unit length, which is Newton per meter, that becomes kg ms minus 2 by meter. Gone. So this is kg s minus 2. Now we have to write here like this, kg s minus 2 is equal to, so energy, which is Newton meter, joule, so kg ms minus 2 meter to the power A. Velocity, meter per second to the power b, and time second to the power c. So if we accumulate all the terms, kg to the power a, meter to the power, so this is 2 here, so 2a plus b, and second is minus 2a minus b plus c. So of course we can see here that kg, so a is equal to 1 on the comparing the coefficients of kg on both the sides. Then meter is 0, so therefore 2a plus b is 0, so therefore b is equal to minus 2a, which is minus 2, and minus 2a minus b plus c is equal to minus 2, so therefore minus 2 plus 2 plus c is equal to minus 2, gone, so therefore c is equal to minus 2. So we'll be having so this was energy, so energy to the power a 1, velocity to the power b, which is minus 2, and time to the power c, which is again minus 2. So e to the power 1, v to the power minus 2, t to the power minus 2. So therefore C option is going to be the correct one. Thank you. If force, velocity and time are taken as fundamental units, the dimensions of mass are. So mass, which is kg, should be equal to force, that is Newton to the power a, velocity, that is meter per second to the power b, and second to the power c. So this is kg ms minus 2 to the power a, and all of them, they are intact. So now we accumulate all of them. So kg to the power a, meter to the power a plus b, and second minus 2a minus b plus c. So this is equal to kg. So therefore a is equal to 1 because kg and this. Now a plus b should be equal to 0 because mass on this side is 0. Okay, so therefore b is equal to minus 1, and minus 2a and minus b, that is plus 1, plus c should be equal to again 0. So therefore c is equal to 1. So therefore what we get is force to the power 1, velocity to the power b, that is minus 1, and time to the power 1, f1 v minus 1 t. So that is D option. Thank you. The pair of quantities having the same dimensions is, okay, impulse. So what is impulse? So impulse is, so we have f is equal to dp by dt. So f into dt is equal to dp. So this is termed as impulse. So this is having the same dimension as that of dp, which is kg ms minus 1. Now the surface tension is Newton per meter, which is kg ms minus 2 divided by m. So this becomes kg s minus 2. So no, they are not having the same thing. Then angular momentum and work. So angular momentum I omega. So this is m r square into omega, which is radian per second. Radian doesn't have any dimension, so we are not writing. So this is kg meter square per second. Work is Newton meter. So therefore kg ms minus 2 into m, which is kg m square s minus 2. The seconds, it's not matching, so therefore this is also not an option. Work and torque. So work is again Newton meter work, so which is kg ms minus 2 into m, and torque is R cross F, which is again meter into Newton. So this is again Newton meter. So therefore this is the option which is correct. And last one, Young's modulus and energy. So Young's modulus, which is F by A divided by delta L by L, which is Newton per meter square, and delta L, which is meter by meter, gone. So this is Newton per meter square, whereas energy is Newton meter. So of course this is also not going to be the correct one. So therefore C option is the correct. The damping force on an oscillator, so therefore this is the damping force, is directly proportional to velocity. The units of the constant of the proportionality are, so we can write F is equal to K into V. So therefore K becomes F by V. So F is Newton, which is kg ms minus 2 divided by ms minus 1, gone. Then this becomes minus 2 and plus 1. So this is kg s minus 1. So therefore C option is the correct one. The dimensions 1 by root over mu naught epsilon naught is what? So this we have to memorize, okay, that the speed of light in vacuum which comes out to be 3 into 10 power 8 meter per second is basically 1 by root over mu naught epsilon naught. So therefore this is meter per second. So therefore L T minus 1. C option is the correct one. The density of material in CGS system of units is 4 gram per centimeter cube. In a system of units in which the unit of length is 10 centimeter and the unit of mass is 100 gram, the value of density of the material will be. So in a system of units in which unit of length is 10 centimeter. So let us say the length is 10 centimeter and mass, we write here mass as 100 grams. Okay. So right now it is 4 gram per centimeter cube. So now we can write here 1 centimeter is equal to 0.1 L, because 1 centimeter becomes L by 10. So therefore 0.1 L, and here we can write 1 gram is equal to 0.01 M, and then we replace it. So 4 into gram is 0.01 divided by centimeter, okay, and this is M centimeter. This becomes 0.1 cube. So therefore 0.001 L cube. So this is 10 into 4 M by L cube. So therefore this will be 40 M by L cube. So this is the unit in the new system, okay, and the magnitude will be 40. So therefore 40 is going to be the answer. The dimensions of half epsilon naught E square. So this is basically the energy per unit volume in an electric field. Okay, so this is energy per unit volume. So therefore joule per volume meter cube. So this is Newton meter kg ms minus 2 Newton meter divided by meter cube, gone. So this is M L minus 1 T minus 2. So therefore B is going to be the answer. If the dimensions of a physical quantity are given by this, then the physical quantity will be, okay, so pressure. So pressure is Newton per meter square, so which is kg ms minus 2 divided by meter square, which is s minus 2. So therefore this is m to the power 1, L to the power minus 1, T to the power minus 2. Okay, so this is correct. For velocity, it's going to be meter per second. So L T minus 1. So B is going to be 1. No. Acceleration, L T to the power minus 2. Where is A coming from? A is not there. And force, Newton, so that is kg ms minus 2. So A has to be 1. Gone. So therefore A is the answer. Which two of the following 5 physical parameters have the same dimensions? Okay, energy density. So the first one is energy per unit volume. So therefore joule per meter cube, which is Newton meter. So kg ms minus 2 into m by m cube. So this is kg m to the power minus 1 s to the power minus 2. Second, refractive index. So refractive index is speed of light in vacuum divided by the speed of light in the medium. So this is basically again dimensionless, because both numerator also it's meter per second and denominator also meter per second. It's gone. So therefore dimensionless. Third one, dielectric constant. Oh, that is also dimensionless. Okay, K is also dimensionless. Fourth one, Young's modulus, which is y is equal to f by a divided by delta L by L, which is Newton per meter square. Kg ms minus 2 divided by m square, which is m L to the power minus 1 T to the power minus 2. And fifth, magnetic field. So F is equal to QVB. So therefore F by QV, which is Newton divided by Coulomb meter per second, that is B. So kg ms minus 2, Coulomb is ampere into seconds into meter per second. Gone. So this is m a to the power minus 1 T to the power minus 2. Now which of them they have the same thing? So 2 and 3 they have the same thing. Okay, 2 and 3 it's same. Then we have this also, the first and fourth, they are also going to be having the same thing. So C option, the first and fourth. Thank you. Dimensions of resistance in an electric circuit in terms of ml, T and I will be. Okay, so we have the heat generated is going to be I square R T. This is going to be the heat generated. So joule, which is Newton meter, is equal to I square into R into second. So therefore the resistance is going to be Newton meter by I square second, which is kg ms minus 2 into m divided by ampere square second, which is kg m square s minus 1 a minus 2 m L square T minus 1 ampere I minus 2. So m L square, this is not there, I should be minus 2, I should be minus 2. So therefore C option is the correct one. The velocity v of a particle at a time t is given by this. Okay, so v is equal to at plus b by t plus c. Okay, so see, this at should be in meter per second. Okay, so this should be equal to a into second. So therefore a becomes meter per second square, which is LT minus 2. Now since this is the only option which is having A as this, we'll just put the B option correct. Okay, but we'll solve for the other constants also. So B by T plus C. So of course when T plus C is given, so therefore C must have the dimension of T. So therefore C is equal to second, that is T. And B by T should be equal to meter per second. That means B should be equal to meter per second into second, gone, which is meter, which is L. So therefore B option is going to be the correct. The ratio of the dimension of the Planck's constant and that of the moment of inertia is the dimension of, okay, so Planck's constant, which is h divided by moment of inertia I. So we know that hc by lambda is equal to energy, which is joule. So therefore h is equal to joule into meter by meter per second, gone, so this is joule second. So therefore Newton meter, kg ms minus 2, this is Newton meter, this becomes joule, and this is second, divided by I, which is mr square. So mass is in kg and r square, which is meter square, gone. So this is s to the power minus 1. Now s to the power minus 1 is actually frequency, which is hertz, which is 1 by time period. Okay, so therefore B is going to be the answer. The unit of permittivity of free space is, so we have force is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. Now if you see here, it's mentioned in coulomb and Newton and meter. So therefore this epsilon naught is going to be as C, this is coulomb square 10 by meter square into 1 by Newton. So this is coulomb square per Newton meter square, which is the C option. So C option is going to be the correct one. The dimensions of the universal gravitational constant are, so this is G. So this was actually Newton meter square per kg square. So this is kg ms minus 2 m square divided by kg square, gone. So this is mass to the power minus 1, length cube t to the power minus 2. A option is going to be the correct one.